Well, hello, welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Hope everybody is well. I hope you've all had a fantastic week. Tonight, we are going to talk to you about Europa Clipper, NASA's mission to an alien moon. And we're going to tell you everything you need to know about that mission, which is exciting, even though obviously the spacecraft's not going to get there for a few years. But anyway, that's for a bit later. We're going to tell you all about this fantastic mission from NASA. Joining us this evening is Aaron. Hello, Aaron.
Oh, can you not hear us?
Aaron has disappeared. Okay, well hopefully he'll come back. We've got him in audio only tonight because his camera's not working, but even his audio seems to have failed. The perils of live broadcasting. Never mind. We got Daz, predictably, of course. Hi, Daz.
Hello.
And
Hello,
we've got
hello.
Michael.
Hi there.
And Roger.
Good evening.
And Andy. Good evening. And Lou.
Greetings.
I hope you've all had a good week, guys, and looking forward to telling everybody about this amazing NASA mission. And we'll come to that a little later.
Have we still got Aaron in the background?
Sorry?
Have we still got Aaron in the background?
No.
Oh, hang on.
No, Aaron seems to have disappeared.
Hold on a second.
So, what have we got to tell you? Oh, Aaron sent a message saying, yes, I'm here. Can you hear us, Aaron? Because we can't
It's the
hear you.
ghost of Aaron.
Okay. But we can't hear you at the moment. So, he's muted. Okay, right. He'll be along in a second. Anyway, welcome to Space Oddities. If it's your first time here, you are most welcome. We are Space Oddities. We tell you about the universe, anything going on in astronomy, cosmology, astrophysics, space exploration, you name it, we tell you about it. And we are always grateful for your suggestions. If you have any suggestions of what you would like to see on these Tuesday live streams, or perhaps as a video on our channel, well, if you go to our Facebook page, the Facebook group is Space Oddities Live. You need to be a member of the channel to subscribe it. So you need to subscribe to the channel. And if you go to the... Who's making noise? Who's making noise? Oh, no. Oh, that's silenced, isn't it? Anyway, if you go to the Facebook group, you can go to the chat, which is called the suggestion box, and anything you've got in mind that you would like to see on the channel or on the Tuesday live streams, do tell us about it. In fact, we had a suggestion from Gerard today. Thank you for your suggestion, Gerard, that we do a show or a video about Carl Sagan, who is obviously, a hero to a lot of people. So I think that's a great idea, Gerard. And I've actually given it to Daz as homework to investigate. So, yeah, I know. Sorry, Daz, as if you haven't got enough to do. But yes, we will definitely bring you something on Carl Sagan because, he's universally admired and respected by everybody. And he's an important figure in the field of astronomy communication. And it's just so sad he's no longer with us. So we will get around to doing that. But anything else you want to suggest, put it in the suggestion box. It's as simple as that. Don't forget, the Facebook group is where we communicate to you, our viewers, what's going on and what we're up to and what's going to happen. So do keep an eye on it, and there you are. Don't forget, of course, that we have several ways that you can support Space Oddities. There's a super chat icon, which is the little dollar symbol underneath the chat, where you can make a donation directly to Space Oddities if you would like to. We also have the ability to buy us a coffee. You can scan this QR link if you would like to buy us a coffee, because any donations towards the costs of keeping Space Oddities going is gratefully appreciated. And as we have some fairly hefty bills to pay later in the year, any donations, any amount you can spare would be gratefully appreciated, no matter how huge it is. So that's that. I'm afraid there is a problem with the software at the moment that normally when we display the QR links, they should pop up in the chat as a link that you can click. That's not working at the moment. And our software providers tell us it's a more complex problem than they first thought, and they're still working on it. But hopefully we'll restore that soon. If you would like to support us in other ways, well, of course, you can buy the Space Oddities T-shirts. We have 2 designs available. And this is the first one, available in 10 colours. I know it's not exactly the time for T-shirt wearing at the moment, especially in the UK, I would guess. It is here, though, because it's still beautifully warm. But, of course, not so in the UK. These are available in 10 colours, and the T-shirts are all £25. But that does include UK postage and packing, so it's a really good deal. You can also buy the other design of T-shirt, which is only available in black, unfortunately. But that's the more recent design. Again, £25, including UK postage and packing. We have the Space Oddities hoodies, and this was the old design of hoodie. And they come in two types: an over-the-head hoodie, where the design is on the front, or one that zips up, where the design is on the back. And that's the old design. And this is the more recent design. And you can find all these if you want to see them all in one place. This is the QR code to scan for the Space Oddities shop. I'll leave that up on the screen to give you time to scan it if you'd like to. And as we have said before, we are thinking about, or trying to actually, expand our range of merchandise with more things coming available. And we will keep you posted in that on due course. Keep an eye on the Facebook group, or come and join the Tuesday live stream. So everybody today is more than welcome to support Space Oddities. As I said, every last bit of money does go towards keeping the channel running. It has no other purpose. We're not all, laying on the beach in Bermuda. Nice as that would be.
There's Andy in a T-shirt and everyone else wrapped up.
That's true. That's very true, Daz. We would all love to be on the beach of Bermuda one day, but we can agree, can't we? So anyway, that's the Space Oddities shop, where you'll find all our merchandise. And we'd like to thank all of you for buying things from our shop, those of you who have. So it's been a really good week for things going on. Not so much in astronomy. There hasn't been much astronomy news this week. So I'm not going to do the normal news, because there have been very few stories worth talking about. But we had a few things going on. Thank you to those of you who joined us yesterday for the launch of Hera. And Hera, as you know, or you may know, is Europe's mission to the asteroid Dimorphos to study exactly what happened after NASA blew a hole in that asteroid as part of the DART mission, the first planetary defense program, to see whether we could actually deflect an asteroid if it were threatening the Earth. Dimorphos isn't threatening the Earth, but it was just an experiment to see what would happen. And it didn't. There were some things that didn't really go to plan in terms of what was going to happen afterwards. There was some rather strange behavior from Dimorphos after the impact. So the European spacecraft Hera is now on its way to examining the asteroid and finding out all about it and what happened after the impact. In fact, Dimorphos is an asteroid that we don't know that much about. We're not sure of its mass. We're not sure of its composition. So this is an important mission. The Hera spacecraft, in addition, is carrying 2 CubeSats that will be deployed and also orbit the asteroid to have a look at its mass, composition, mineral content, and so forth. And those 2 CubeSats will actually eventually touch down on the asteroid to give us some in situ measurements. So it's a very exciting mission. So thank you for joining us for the launch on a Falcon 9, SpaceX Falcon 9 yesterday. Went incredibly well, no problems. And here was the actual moment that the spacecraft was deployed from the second stage of the Falcon 9, and it was something that we didn't carry live because it actually didn't get deployed until it had completed, I think,
MVAC shutdown
orbits of the Earth. So this was the moment. As you can see, this is the last time we'll ever see Hera in the flesh, so to speak, as SpaceX launched it on its way to the asteroid. And
Hera separation confirmed.
And if you just wait a little, you will see a beautiful view of the crescent Earth coming into view. Stunning view. So there goes Hera to examine the Dimorphos asteroid and to find out exactly what happened after NASA's DART spacecraft destroyed itself by crashing into it. and it's reaching here. It's reaching the asteroid in December of 2026. So we got 2 years to wait, unfortunately, to get that. But isn't that a beautiful shot?
I think it's going to say, "We're sorry, we didn't mean to smack you."
Yeah,
Yeah.
Be more
right.
gentle this time.
It's got a big band-aid. It's got a big band-aid he's going to put on there.
But did you see what they've actually engraved on the side of the spacecraft? It's really funny. They've engraved a dinosaur. There's a picture of a dinosaur on the side of the spacecraft, as if to say, "This is the dinosaur. This was the dinosaur's revenge." So
This is Aaron.
It
You can hear me.
Okay, carry on, Aaron.
Oh,
Sorry,
you can hear me. Wonderful. All right, I have audio, just no video.
fantastic.
What I was impressed with, I missed the dinosaur on the side of the spacecraft, but I was impressed that SpaceX is using tie wraps to hold things together.
Oh, absolutely.
Yeah, I saw that.
Yeah.
Zip ties, yeah. We
The
call them
budget
zip
is
ties.
the budget that we.
Well,
Yeah, I
actually, that budget was under severe threat, and they had to make lots of compromises on the design of the spacecraft to get it in their reduced budget. So yes, the fact they're using tie wraps doesn't surprise me at all. So anyway, that was
if Boeing or anyone else used them, that zip tie cost you about $150
that's
just
right.
for one.
That's
So
right. Yeah, exactly.
dig in.
Yeah. So what else has been going on this week? Well, as you may know, there's a very important telescope under construction or nearing the end of its construction in Chile, the Vera Rubin Observatory. And this is a revolutionary telescope that will survey the complete southern hemisphere sky and take photographs of all of the southern hemisphere sky every 3 days. And this is a very important telescope. It's a survey telescope, wide angle telescope that takes pictures of the night sky and generates incredible amounts of data. But the idea behind this is that we'll be able to see things changing out there in the cosmos. So this is what's called time domain astronomy, where we, instead of taking images every so often, the Vera Rubin telescope will be taking photographs all the time and doing the complete southern hemisphere sky every 3 nights, and it's going to do that for 5 years, I think, if I remember the duration. We stand to see a lot of changes, whether it's asteroids, supernovae, whatever, and it's reckoned that it's going to completely revolutionize our view of the night sky and see things that we would have missed up till now. Very exciting project. It's been underway for years, and initially it was called the LSST, which stands for the Large Synoptic Survey Telescope, and it was rechristened the Vera Rubin Observatory a little while ago. But I've been following this since it was the LSST, and that is years. So it's very exciting to see this come to fruition. It should see first light maybe around the middle of next year, if all goes well. So we're really excited about that. This week was a very important stage in the development of that telescope. It was the installation of the main mirror. And this mirror will focus light onto the biggest digital camera ever built, which is about the size of a car, the highest resolution digital camera ever made. It's a massive thing, as you may have seen. We've talked about this on the show before. But this was the moment or the process whereby they installed the mirror. And there's the mirror, and it's very clever how they do it. They put it into this lift. And then that lift goes up. As you can see. And then up it comes to here, and then it slides into the dome of the telescope and is mounted on the mirror mount, or will be. I don't think they've done it yet, but they've got it inside the dome. So this was a momentous day for the Vera Rubin telescope. And it is, as I said earlier, going to revolutionize observations of the night sky. We're going to learn lots and lots of things from the Vera Rubin telescope. But it's great to see the main mirror finally being installed. because I'm thrilled, as I said, because it's been built for years and years. It's been under construction or design and construction for years and years and years. Wasn't that great, guys?
Yeah.
Yeah, it certainly was.
What size blower brush are they going to get the dust off with?
That's a good question.
I was thinking more of basically put fluffy socks on and just skate around on it. It was so nice.
It's lovely
I
seeing
think
a
they'd
15-year-old
appreciate
like
that.
Yeah.
I don't think they'd appreciate that.
It's going to need a big lens cap in it.
Yeah, absolutely.
I think that's an amazing amount of technology for something you will seldom have to use. To move that mirror in and out of the telescope.
Oh, yeah.
Absolutely. But I mean, I suppose there was no other way of doing it.
Yeah, I know. Amazing, though.
Yeah, absolutely amazing. But it's done, and it looks like it's been successful. And there we are. So
could there be a son of Vera Rubin in the future?
Well, might be. Who knows? But this is the first of its class of these new survey telescopes. I'm not sure if any more are planned, but I suppose it depends on the scientific value of what it actually gives us. As I mentioned before, every time that it sees something change in the night sky, it will generate an email alert, which will be sent to anybody, including the public, who want to receive the alerts. I wouldn't recommend it, though, because apparently it's meant to generate around 2 or 3 million notifications a night. And if you want 2 or 3 million emails in your inbox when you wake up in the morning, then by all means go ahead and subscribe.
Make sure you have a dedicated email address for it.
Yeah, absolutely. And,
so, Andy, if I could jump in here, I see we have a question from Ian. Asking who Vera Rubin was, and I have a very good answer because I have a card here on Vera Rubin. In the 1970s, she was an astrophysicist. She discovered evidence that the universe was made of more than what could be seen with telescopes, today known as dark matter. She's born in 1828. I'll skip the personal stuff. Her passion would lead her to become the sole astronomy major in her graduating class at Vassar in 1948. After Princeton denied her admittance to graduate school due to her being a woman, a policy that stood until 1975, in case anyone's curious. Anyway, Rubin pursued her advanced training at Cornell and then Georgetown, where she completed a PhD. She was a lifelong advocate for women in science and scientific theory.
Well, there you are.
Lovely.
Yes, indeed. And in fact, when she used to go out in the evening to the pub, people used to say, "Oh, look, there goes Dark Vera," and that was her nickname.
Oh.
I'm only joking, of course. But anyway, something else I wanted to say to viewers today. Believe it or not, we do have people who watch us regularly who are, shock horror, not subscribed to the channel. So please, if you could subscribe to the channel, it's going to really help us. And I know it's a bit of a hassle having to go to the channel and click the subscribe button and then say, yes, you want to subscribe. So I made it easy for you. So I'm putting this link in the chat now. If you actually just click that link, that will take you directly to the Space Oddities channel, and it will immediately ask you if you want to subscribe. And here's a clue. You click yes. So if everybody could remember to subscribe to the channel, that would be fantastic, because, it helps us, and it helps the YouTube algorithm notice us more. The more subscribers we have, the more people see our videos. And there we are. If you could do that, that would be absolutely fantastic. By the way, that link only works on computers. It does not work on mobile devices. So if you're watching us on a phone, it's not going to work, unfortunately. But it does work on computers. So there we are. So let's have a look. We've got a Space Barnes is back. Nice to see you again, Space Barnes. Says, I wonder if by comparing images taken by women at the furthest extremes of Earth orbit, we'll be able to measure distances of remote objects with a higher degree of precision. Yeah, absolutely.
I think so.
I don't see why not. Yeah, good question. Thank you very much. Yeah,
because it's basically just looking at basically time domain things, isn't it? It's just to notice anything different and then examine what's actually happening, like supernovas.
Yeah, exactly. And asteroids and novae and anything changing in the sky, basically.
Yeah, exactly.
So it's going to be a fascinating observatory. Sandra, thank you, Sandra, points out quite rightly there's an area in Gale Crater on Mars called the Vera Rubin Ridge. So Vera Rubin, of course, is commemorated in a few places. I'm not sure if there's a crater on the Moon named after Vera Rubin. I wouldn't be surprised, though, because she is quite a big figure in astrophysics. And, you know, as Aaron quite rightly pointed out, as a woman, she had to struggle to get the recognition and to be able to study. Because I was reading recently that in the United States, I don't know how true this is. I did read it, so please somebody correct me if it's wrong. Aaron, you might be able to correct me. That many universities in the US didn't actually accept women for degree courses until about 1965, when things began to change. So you know, I'm sure Vera had a real struggle on her hands. So
because she basically made the discovery hinting at dark matter.
Yes.
By studying galaxies, wasn't it, in their rotation?
That's right. It was a rotation curve.
And how the outside should be, and let me get this, traveling slower, but it's not. It's matching the pace of everything that's on the inside. Which the only reason it can do that is if there's something there that we can't see, given it extra mass. So that was how it worked. So
yeah, it's, you know, because these crazy Mond people have, you know, ridiculous explanations for that. So, you know, I'm looking at Lou, of course.
Yeah, of course.
Hey, I'll have the last laugh on that.
I heard the grinding of teeth there.
Well, actually, what Lou and I have talked about doing one Tuesday is to have the great dark matter versus Mond debate. So if you're still up for that, Lou, I think we should do it soon.
I love the idea. The idea.
All right,
in the blue corner.
Keep an eye on the Facebook group, viewers, and we'll announce it in due course, because it is a debate that is unresolved, and you know, there's evidence on both sides, and I was reading, I think it was Dr. Becky on YouTube, did a very good summary of all the pros and cons quite a while ago now, but basically she said that you know, the solution may be a mixture of dark matter and Mond.
Or something completely different.
Or something completely different, indeed. But we will discuss that. We'll come up with a date for that. We'll have a
could I share my screen briefly? I'll just show something.
Go on, you devil.
That has referenced here. Here it is. This is just from Wikipedia, but it shows a typical spiral galaxy rotation curve. And the dotted line is what you would expect from Newtonian gravity.
Yeah.
And the line with all the data points on it, the yellow and blue data points, are in fact what we observe, that the galaxy doesn't the rotation curve of the galaxy doesn't slow down as you go outside from the core. So.
Yeah. And the explanation for that is that the galaxy is embedded in something a lot bigger, obviously.
Needs more mass by about a factor of 8 to 10.
Absolutely. So thank you for that, Lou. Yeah, so that's something we can have a chat about, and we'll let you know when that's going to happen. We'll get something together for you. And don't forget, just to repeat myself, if you have any suggestions for anything you want to see on our Tuesday live streams or as a video on the channel, go to the Space Oddities live Facebook group, after you subscribed, of course, and put it in the suggestion box chat, and we'll look at it and see whether we can do it for you, which we always hope to do. Okay, moving on. I think we'll go over to Roger next. If you're ready, Roger.
Good. I am.
I really woke him up
ready.
Then. Mind you, it's not often I have to wake up people when we're doing a live stream. Is it, Michael?
No, it's not really.
Michael was so thrilled with the launch of Hera yesterday, he fell asleep in the middle of it, live.
Yeah, well, they did launch it as a nap time, his afternoon nap
that's
time.
Right. That's right.
But of course, Roger's tired because he's been away the weekend to the local pirate festival. So
I
did see
Wow.
the photos.
Yeah. Yeah, I mean, you know, it was his nap time, and he hadn't put his slippers on and had his Horlicks, nor put fresh tobacco in his pipe, and he was feeling rather weary. Yeah. Oh, Aaron says he assumes it's him, but he's lost connectivity completely. Well, we can't answer if
it's
he's
you.
lost. Yeah, it's Aaron. So there we are. You probably can't see that if he's lost connectivity.
Yeah.
Well,
Yeah.
when he rises from the dead, he'll see it.
Yeah.
Use the force, Lou. Use the
it was
force.
actually my siesta time yesterday.
Yes.
And yesterday morning I walked about 5 miles, and I was quite tired, but I didn't drop off in the
No,
middle.
you did not.
No, you
Oh,
see.
yeah, but did you tell them why you walked 5 miles, Andy? You had to go back in town because you forgot
Yeah, exactly.
something.
No, I didn't. I didn't forget anything. I can't remember why I did it.
That must be
I can't
case,
remember why I walked into town twice.
Because it was there.
Which is over 4 miles. Anyway, yeah, it's hilarious. Michael falling asleep. You see, we made him laugh, Michael. You should do more often. So, yeah, absolutely.
Oh.
So, it was just a look on his face when I shouted at him. So, wake him up. Bless him. He looked like a fox in headlights. So, so there we are. All right, Roger, sorry.
Hello.
You're bursting. You're bursting with anticipation about what you're going to show us tonight, aren't you?
Yes. Of course I am. Okay, so here we go for the second week of October. And we're gradually working our way through the phases of the moon, which will be first quarter on Thursday. So there we go. A brief spell of clear skies showed what activity there was on the sun yesterday. And obviously, the activity isn't doing too badly. No doubt we'll get a spoiler alert for later on to fill us in on what's been happening or not over on the sun by my fellow oddity person.
Oddity?
Oddity person, right. So here we are for at midnight through the week, and we've got a lot of activity going on in planet situations. We've got Saturn, we've got Uranus, we've got Jupiter, we've got Mars. So it's all going on now. It's all building up. And as you can see in the eastern horizon, we've got Orion making an appearance now.
Yeah.
So all looking well. We've still got the summer triangle up, although that is now heading over towards the western areas of our skies. But even so, it's starting to move on to the winter constellations. Yay. So things are looking up. And by the end of the month, we'll be putting our clocks back. But before sunset, we've got Mercury quite nearby and a little bit further away, but still quite low in the western horizon, we've got Venus. And on this slide here, we have got Comet Sutchinson Atlas, which will be coming more into our evening skies later in the month, but I will tell you a bit more of that shortly. So as you can see from the slides, you can see it marked getting further up into the sky. So things will be looking a lot better for comet hunting. Some of the photographs are absolutely amazing. It's got a nice long tail. Anyway, we have, if you're interested in the gas giants, we've got a Rhea transit on the 10th of October, although it is just over on the 9th, 10th of October, where it's in the wee hours in the morning, just after midnight. So if you want to see any of activity of transits, just make sure you can see these things. It might be a bit difficult to see. You will need a fairly decent size telescope, probably about 8+ inches or so to get to see it. But it's an advantage that we can take while the inclination of the rings is quite small still. So interesting thing to see. And on the 11th, we've got Titan over the northern area of Saturn. So another interesting opportunity to see the moon over the northern poles. Back to the comet, on the 15th, there's a photo opportunity of it near the M5 cluster. So might be a good opportunity there, although it will be a bit low down on the ground, and it might be a bit bright there for any photo opportunities due to it being fairly soon after sunset. But an opportunity is an opportunity. I've just marked out the position of the comet coming up through. Obviously, I'm suggesting that anything from about the 15th or 16th onwards would be better due to the brightness of after the sunset glow, but it will be traveling through a fucus, so keep an eye out on the western horizon, and it will be getting much higher as each night progresses. And although it will be into the 5 and magnitude 6, it still will be a reasonable object to have a look at. Okay, there are some interesting objects to come. Just to say that the comet will be at perigee this coming Saturday, where it will be just over, well, nearly 43 million miles away. So anything after that, it will start to dim, but it will gradually dim. But there we are. Okay, so we have got from the James Webb this galaxy cluster, and it's got some interesting lensing effects here, as you can see from the center of the image, which I will go to the next slide to give you a closer view. Now, what it's managed to pick up, which is highlighted in the part of the picture on the right, is a supernova. Now, due to the gravitational lensing effect, it has shown the same supernova at 3 different time periods. So it's quite an interesting viewpoint of how a supernova is gradually expanding due to the gravitational lensing effects that we are currently seeing. So once they manage to do some calculations on that, we might be able to get a new value for the Hubble constant. So we'll see if any amendments need to be changed on the Hubble constant to see how that might work.
And that's gravitational effects from relativistic applications of Mond theory, of course. Is that right?
Roger? Yes, yeah. I guess so. Yeah.
Just wanted to clarify. Just okay. Audience to be confused.
Can I just say that this has enabled further measurements to do with the Hubble tension, the rate of expansion of the universe, and it's really put the cat among the pigeons, because it again has come up with a figure of 73 kilometers per second per megaparsec, which is at odds with the measurements we get from the cosmic microwave background. So this is, again, perpetuated this what's called the Hubble tension, this disagreement between the 2 main methods of measuring the rate of expansion of the universe, that is to say, from the cosmic microwave background, dating from the very early universe, and supernovae like this, dating from later. And this discrepancy, the Hubble tension, is one of the biggest questions in astrophysics. And the more that the Webb discovers, the tension goes on. So there we are.
It's only a few kilometers per second. I mean, come on.
Yeah, but it makes a big difference in the grand scheme of things.
Okay. I see that Kevin Earp has said that there is a crater.
Yes.
And it's about 4 kilometers in diameter. So
yeah. The
small, but there is a name.
Yeah, absolutely. Thanks for that.
I've been trying to confirm that. The link I looked at said there's no crater for it. I'm not disputing what Kev's saying at all, but there's a bit of a confusion here. It says about the ridge on Mars, but yeah, I will delve deeper, see if I can get an image.
Okay. You know what's kind of interesting about that? In the early '60s, when we started sending spacecraft to planets, there became a rift between astrophysicists, or what you might call real astronomers, and planetary scientists, because the planetary scientists could then go there, land on it, pick up some dirt and look at it. And of course, real astronomers don't do that. They just look at the frequency and intensity of light. And so the 2 groups kind of migrated apart. And within the American Astronomical Society, for example, there's their own separate little division called the Division for Planetary Sciences now. So they were very nice to name a crater after an astrophysicist.
Yeah, indeed. Indeed.
Good. Right.
Yeah. So,
we've got another large gallery for this week. We have got quite a few images from one of our Space Oddities members, so which is not me.
Oh.
Oh. But I'll start the kick off with some of my solar images from the other day. So as you can see, some interesting activity going on here.
Oh, lovely.
Yes.
So yeah, quite pleased with. It's been quite interesting activity with the prominences over the last week or so. So it's nice to be able to get some myself with a clear day or so. So that was a bit of a novelty. Right. Okay, we've got one from Sonia with her sea star and some solar films. So gives you an idea of some of the groups of sunspots that we've currently experienced at the moment.
And some modeling on the surface too. That's very nice.
Yeah, absolutely. Very nice.
Yeah. So there we go. And we've got a few from Pete. There's quite a few solar images this week and some lunar images this week taking up the gallery, which is nice to see. So this was on the 4th of October with his solar telescope.
Lovely.
Wow.
Well done, Pete.
Some of the activity getting on with that.
Beautiful.
And we've got some, and here's, hang on. And here's a color version of that image, just in case.
Lovely.
Striking.
Just in case you liked it in color.
Which we do.
Lovely.
Which we do. Yeah. Okay.
Beautiful.
And then we've got another one of 3848 with his solar scope.
Wow.
And
My gosh.
Now that filament looks almost as if it's sticking out into the atmosphere there.
It certainly does.
Yeah.
So
that's scary.
Yeah. Very scary.
Very scary.
Very scary. And here's one that he took with the 2-meter telescope. As you can see, there was just three images, red, green, and blue, and 15 seconds. And this is what he got.
Oh,
well,
beautiful.
Wow.
We should point out that Pete does not own a 2-meter telescope, of course.
No.
Pulled it out of his closet, did he?
Yeah.
This is the Folks remote telescope.
Yeah.
That's
not bad
lovely.
for 15 seconds, is it?
Not bad at all. Well done, Pete.
Thanks.
Lots of nebulosity there in the arms as well. So he's done well there. And some Juno data from Pete, just processed in Photoshop.
Oh,
lovely.
That's a good one.
Wow. We've been talking recent weeks, haven't we, about perhaps our viewers having a go at processing their own data, not just from JunoCam on board the Juno spacecraft, but any NASA image you can download and process because it's all in the public domain, and it just goes to show that you can get amazing results. And that red spot is very red, isn't it?
It is.
Certainly is.
Yeah.
Yeah.
That's
see
from the
worlds
student
in it.
That's from the student camera, right? The university students put a camera on at low cost. And I wonder. I don't know about the camera. I wonder if that's a true color image. I don't know. It's a beautiful picture. But.
It is.
Anyway,
Definitely.
Let's move on. And here's one which is a blend of the Folks data and from Hubble.
Oh,
Wow.
yeah.
Wow.
Whoa, that's nice.
Yeah. Definitely. Amazing.
Isn't that sorry, I missed what that was. Isn't that Centaurus A?
Yes.
It is.
Yeah.
Yeah.
Beautiful.
Yeah. Not something.
Those
Not something visible from the back garden.
No. Those incredibly thick dust lanes, they are just unbelievable.
They certainly are.
Yeah. No evidence of dark matter, though, I don't see. So.
I don't see any evidence in Mond either.
No.
Okay.
They're sharpening their knives.
Right. So we've got
the space.
We've got the Crab Nebula from Jerry DeLay with
Jerry.
With his usual setup, and this is what we've got.
Oh wow,
that's lovely.
That is beautiful.
Great definition.
Very nice.
That's fantastic.
Got lots of veins and stuff on that one.
That's gorgeous.
Amazing. That's
well done, Jerry. That's
what I like about the Crab Nebula is you can go back to the 60s and they've created a time lapse of the actual Crab Nebula expanding.
Yeah, I've seen that.
So you can actually see it growing and growing. And of course, it was there before then, but you can actually see it growing and expanding. It's how it's changed over the years. It's absolutely gorgeous.
Yes,
very nice, most impressive. And we've got one from Neil Barnes. So we've got a couple of images of the moon which he's taken. So he's used an old scope. So he was doing a 4K video with it with his Olympus camera.
Yes, it was actually my old refractor telescope that he was using.
Oh, right.
Yeah.
So he's processed it with AstroSurface and PIP, and using GIMP as well to get the images. And this is what we've managed to get.
Neil, if I had a goldfish, you would win it. Definitely.
Yeah, I was just going to say he wins a goldfish.
Yeah, well, I have got goldfish, but you're not having them.
So he's got some good images there.
Yeah.
With him, how he's managed to do it. Quite impressed.
Oh, you've got the X in the bottom, haven't you?
Yeah, good to see you.
Yes, he has. Well spotted.
Yeah, he's got the X at the bottom.
Oh, the X. What's the X?
Yeah.
The elusive X.
Yeah.
Yeah.
Well done.
There it is. Well done. Well done. They're lovely. Thank you so much.
And then we've got another one from Pete on the 5th of October of a flare-up. Ooh.
Lovely.
Nice.
More scary pictures.
More scary pictures, yeah.
There'll be some scarier ones later.
Okay. Right, so that concludes the gallery that we've had from our members. Thank you all very much. And been quite interesting to see all the contributors putting in some images. So
yeah, thank you. That was
send
great.
more in.
Yeah, that was lovely. As regards Titian Atlas, I'll be having a bit of a surprise for you there, Rog, later on. But as regards the Vera Rubin crater, Kev's corrected me and he said, yeah, there was a crater named after Vera Rubin, but it was only named March this year. This is why I had trouble finding any details on it. So thanks for that, Kev. Thanks. Even we've learned something. Fantastic.
That is amazing. Look at that. Okay, is that it?
Yes, all done.
All done. Right, thank you, Roger, as always.
Thank you, Roger.
Well, I was beginning to think I lost my connection.
So, yeah, no, Roger went quiet. I was getting a bit worried, but there you are. That's it. Thank you so much, viewers, for sending in your images. Don't forget, if you would like to share your images with us, then pop them in an email, address it to spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. One image per email, please. And if you could put the word gallery somewhere in the subject of the email, then...
Andy, there was a question from, let me just do this, I'll just pop it up, from Sandra.
Yeah, I saw that. I was going to go through that one about the red spot. Perhaps Lou might like to answer this one.
I can't see it on my screen.
Sandra says.
Oh, sorry, I've just took it. Nobody touch out of it.
Is it the different gases that causes the red spot to be that red?
Yeah, I think so. I think we're seeing deeper into the atmosphere of Jupiter, and as you do, the temperature changes and different gases come out of solution and condense. And I don't know exactly what the composition is. I don't, but fundamentally, I think that's what we're seeing.
Because if you look at a sort of a 3D model of the red spot, it is quite deep in the atmosphere. It's not floating on the surface. It's actually quite a way down, isn't it? Mm-hmm. I can't remember the exact depth, but it's much deeper than the rest of the atmosphere.
Yes, and I think this is a primary reason that the belts and zones are different colors and different hues, because let's see, the belts are downwelling air, so you're seeing deeper into the atmosphere and warmer temperatures. The zones are upwelling air, so you're seeing higher up and different gets out. So it's all temperature driven, I think.
Yeah. So Neil actually says just a bit more information about his image there. Lovely images of the moon. The low res image is the RAO 77, the others from an Altair 102 ED. So now we know. Thank you very much, Neil, for clarifying that. Fantastic images. So, and Derek says, great images again. Chaps, well done. So thank you all. Don't forget, you don't have to use expensive equipment to generate images that you would like to share in the gallery. If you've just got a mobile phone and you've taken a photograph of the night sky or a skyscape or whatever it is that you want to share with us, because we love looking at your images.
You could even sketch it if you're a
absolutely.
Sketch it.
So there we are. Okay, Sandra says, I didn't realize it went deeper. It thought it was just on the surface. No, it's actually some distance below
It's a massive cyclone, isn't it? It's like a hurricane.
Yeah, it's
so
like
it digs really deep into.
It digs really deep into the atmosphere, and it is the surface of the red spot is some distance below the level of the surrounding clouds. Although I can't remember the exact figure, but I'll try and come up with it by the end of the show. Talking about the comet, just give me 1 second, because Southern Hemisphere viewers have had fantastic views of this comet. So let me just... Oh, what happened there? There we are. Look at that. Wow. That was Astronomy Picture of the Day a few days ago.
Where was that taken from?
That's a very good question. I'll just tell you now. This was taken at Santa Catarina in southern Brazil.
Mm.
So they are. But if you look closely, look at that lovely moon right on the horizon.
Yeah. But also look at the sorry, look at the length of the tail.
I know. This comet has an incredibly long tail.
Mm.
Let me just see if I can zoom in on that for you. Just give me a second.
Oh yeah.
It's gorgeous, isn't it?
It does present itself a lot longer than that.
Does it?
So, yeah.
Yeah.
So,
it is incredible.
We'll all find out in the next week or so.
Yeah, absolutely. Just give me a second, because there was another image of it more recently. Let me just find that. I think it was not that, obviously. Let me just find this. I can't remember exactly. There we are. Look at that.
Look at
that. That's quite amazing, isn't it? Let me just maximize that, get our ugly mugs out of the way. There we are. And again, if I just zoom in on that a little bit.
Has it got two tails? Well, of course it could.
It's got the ion tail,
Got the ion tail and the dust tail,
it's shown an interesting sort of wrapping around the tail of the ion tail, was showing quite a lot of movement on there.
Yeah, isn't that beautiful?
Yeah, it looks like NORAD's fired 2 missiles at it. They're paranoid as usual.
Needless to say, when it hits our skies, it probably won't look anything like that.
Don't do that, Andy. Come on.
It's not. It's I'll shut up because I'm so cynical about comets because they're never as
You're bringing us
advertised.
down, man. It's the bad vibes.
Listen, I've never quite got over the shock of Comet Kahootek, so yeah.
I know the feeling, Andy.
The sheer disappointment of Comet Kahootek that nor the media was going to be the brightest thing. It was going to take up a third of the night sky.
Yeah.
And, I went down to the foreshore at Leigh-on-Sea in Essex, where I grew up, and my father brought along a pair of binoculars, and it was a small binocular object. You could hardly see it at all with a naked eye. So, that's when I've developed a deep mistrust of comets. I hate them.
Yeah. I think we've lost Lou. Oh, he's back. He's back. Good.
Okay, well, that's good. Okay, well, let's move on then to talk about Europa Clipper, guys. So I think what we'll do, Lou, if you'd like to tell us a little about something about Europa itself, and then we'll get Michael to tell us about the actual spacecraft and the mission.
Oh, sure. Okay. Well, let's see. I loaded up my...
Okay, here we go.
So if you can...
Right. So...
There we are. So I had a little fun with this, actually, because I got to go back and look at some of the history of how Europa was discovered and play some games with that. So I'll talk a little bit about that history. And then we'll get into why the heck we're spending hundreds of millions, actually perhaps over $1 billion, at least the US, on Europa Clipper. And then the ESA is sending a spacecraft to Jupiter. What's going on here? Why aren't we spending this on better video games, which I think would be a much better solution? And we'll talk a little bit about that. So here we go. Okay. There we go. So, Galileo in 1610 pointed his telescope at Jupiter, and he saw these 4 stars. Well, actually, originally 3 stars, and then as he watched them over the days and weeks, another one appeared, and he noticed that they were orbiting Jupiter. This was a real problem because nothing was supposed to orbit anything except the Earth. Nevertheless, this is the observational evidence, and originally, he called these moons not the Galileo moons, Io, Europa, Ganymede, and Callisto that we know today. He called them the Medicean moons, after Cosimo de Medici. And Medici was a student of Galileo's in mathematics at one point. And I guess he didn't decide to pursue a career in astronomy because he became quite wealthy. And in order to gain favor with his wealthy former student, Galileo named the moons after him. So it stood that way for a long time until, I don't know, I think maybe the 1800s. And then we decided, well, no, we need to name these after Galileo. So those were Io, Europa, Ganymede, and Callisto. And here is what you saw in the first slide was the actual notes that Galileo took, noticing the different positions of those moons. Here we're able to actually identify which moons were which by going back with modeling software. And so you can see I is for Io, E is for Europa, G for Ganymede, C for Callisto. So you can actually see where Europa is in the sketches that Galileo took. And we can even model these in motion. This is an animation, which won't show here, but you can actually model these in motion. So that's the way it was for the longest time. They were just kind of points of light in the sky. But I dredged up these 4 images from 4 different spacecraft that were sent to Jupiter. Pioneer 10 didn't really do Europa much of a favor, but it's the first close-up image, nevertheless, of Europa. And then Voyager 1 in 1979 produced a much better image with color and indicating different composition and irradiation of the surface. The Juno spacecraft has a much, you can't really tell here, but a much higher resolution imager. And of course, Galileo returned very, very close-up images of Europa. So we started to understand that this is a world that is of some interest. And we began to form an image of Europa as a world that is not only icy, but filled with water. In fact, more water than is in all the Earth's oceans. And I'm going to talk about why that's the case, because that is a primary driver of the reason we're spending so much money to go back to Jupiter. I mean, here are 4 missions, right? You'd think that was enough. No. To go back to Jupiter, and as you'll find out a little bit later, the Europa Clipper mission was designed initially to be an orbiter and a lander. The lander was kind of cut after its prime supporter in Texas didn't get reelected, but I won't say any more about that for now. Okay, so that's what you can do close up from spacecraft. Here are some Hubble images of Europa. I showed all the moons here. They're all kind of one deal in a sense, but they're all very different because of their distances, primarily because of their distances from Jupiter. And so here's the best you can do from, as we'll say, Earth orbit for Europa. And if you all are interested, you can find ground-based images of Europa using techniques to still the atmosphere. Okay, but as I was saying, why Europa? Why do we care? It's very competitive getting money for planetary missions. Uranus and Neptune, they're out there waiting for us. So far, there's not much money for them. But here we go with Europa. So let's see why Europa. Well, let's understand just a little bit about Europa. Here's just some fun facts, you might call it. It's about the size of our moon. Okay, it's 5 astronomical units away, which means it receives about 1/25th as much light, sunlight per square meter as we do at the Earth. It is tidally locked to Jupiter, which means it shows the same thing orbits, just like our rather cold. It has an atmosphere, technically. There are technically atoms and molecules that levitate over the surface, not in much abundance. However, the fact that oxygen is there is very important, as we'll discuss. It's small and rocky with an icy surface. You can walk on it. It's one of the icy outer moons of the solar system. We call them icy moons because water could condense in the outer solar system as it was being formed. And so many of the moons in the outer solar system have ice on their surfaces, and so on. I mean, you can kind of just see this. So that's kind of, physically what Europa is about. But as I mentioned before, Europa, we now believe, has a subsurface ocean. And one of the things that allows that ocean to exist is the fact that that Europa is locked in a 1-2-4 resonance with its fellow Galilean moons, Io and Ganymede, which means that Ganymede goes around once, Europa goes around twice, Io goes around 4 times in the same amount of time. And it turns out that this resonance is important in this story because, number one, it maintains Europa's eccentricity of its orbit, which is not much, but it's enough. And it also keeps Europa from spiraling into Jupiter over time. And so these 2 factors allow Europa to maintain conditions that are favorable for a moon that would need to have an internal heat source that is caused by the progressive pulling of Jupiter on this moon as it goes around, or differential pulling over time. Okay. I'm going to walk here a little bit. Turns out I found a classroom that is about to start class. So I'm going to walk into another room here.
Wonderful.
Okay. All right, so that's the deal. You have to maintain an eccentric orbit so that Jupiter can have a differential pull, creating friction below the surface.
Hang on, Lou. Your sound is terrible.
My sound is terrible.
Yeah, got a lot of interference.
All right, hang on.
Oh, that's better. You still with us? Right, we appear to have lost Lou. Just give him a second to sort himself out. He's having to move because he's ensconced himself.
I'm here.
There you are. There you are. Okay.
Okay. All right. So just to say again, the primary heat source inside Europa is this tidal friction. There's a little bit of radioactive decay in the core, we believe, but primarily this tidal friction that allows that to stay warm enough to maintain an ocean. There we go. So this might look a little bit like this. The ice sheath is believed to be perhaps 10 to 15 kilometers thick. There are a couple of models. Some have warm ice coming to the top and connecting with the colder ice above. Some have simply warmer waters connecting with the ice. And this kind of drives the various topography that we see on the surface, where you might have geysers, which are still to be observed, I think, on Europa, as well as what we would call on Earth sea ice ridges, that kind of thing, as the oceans bulge and push against the icy crust. The images of Europa show patterns of cracks and ridges, and that, of course, suggests this global ocean allowing for large tides. And these tides deform the surface, producing these features. And you see impact structures, which appear round and concentric, that suggest that these impacts may have actually penetrated through the ice shell into liquid water, and the water then comes up and kind of smooths things over. This is important because I mentioned water, okay, water is important, but water is important because that's where you find life. And in order to have life, you need energy, you need water, and you need a nutrient-filled environment. And that nutrient-filled environment can come from impactors coming in and breaking through the ice, and it could also come from ocean surface volcanoes that we see on Earth. So all of those are possibilities. So let's see here.
So Lou, I just need to comment that I'm a little disappointed your artist's rendition did not include any critters.
Oh, well, thank you for that. Let me say a word about that. I have a good friend. His name's John Cooper. He's a brilliant scientist, a planetary scientist. And we were kind of joking around one day, and he said he thought we should go looking for whale bones on Europa. And I laughed, and he said, no, think about it. If there is life below the ice sheath, and you have a major impactor that comes in crashing through the ice, then you're going to get a splash, right? You drop a rock in a lake, there's a splash. And that splash could hold subsurface ocean creatures that would lie on the surface forever, and you'd find whale bones on your butt. I'm just saying. One of the reasons that we think another reason that we think that there is a subsurface ocean for Europa is that as you fly a spacecraft by Europa, which has no global magnetic field of its own, the magnetometer on that spacecraft will twitch, indicating that it is sensing a magnetic field from the moon. And it's believed that this is due to current flowing in the subsurface ocean, which would be a saline ocean. Saline water conducts electricity. And as electricity flows, it generates a magnetic field. We know this from the 1800s, from Michael Faraday. And so it's believed that there's a dipole set up here that is generating a magnetic field within Europa that can be detected as the Jovian magnetic field kind of moves through it as Jupiter rotates. So that's another piece of evidence that there is a subsurface ocean. So just a picture of the surface of Europa, a high-resolution picture. I think this is from Galileo, and you can see some of the ridges and deformations in the surface that would be allowed if you have tides that are kind of heaving and lowering over time, producing these kinds of structures. Oops, did I do something wrong? There we go. So once again, a model of what this might look like. Water shooting through some cracks in the surface, and Europa Clipper will certainly be looking for that. Water upwelling and pushing up against the crust, creating some of these surface features. And then also, once the water is, if there are water geysers, the radiation from the sun will break that apart into oxygen and hydrogen, and that would account for the oxygen that we see in the minimalistic atmosphere of Europa.
It's worth pointing out as well, Lou, isn't it, that the Hubble Space Telescope seems to have actually seen these plumes.
Hubble has seen the plumes, okay, and so I wonder if you'll be able to tell us if Europa Clipper would like to fly through one of them, as we did for Enceladus.
Yeah, that'd be fantastic.
So we have an ice shell. These are some remaining questions. We don't know exactly how thick it is, but Europa Clipper will help us resolve that. We're not entirely sure of the surface composition or the physics and dynamics of the tectonic motion of the surface, and then the actual rate of oxygen production remains to be seen. So the question is, why are we going? Well, we're going because it may harbor life, and we have all of the elements necessary. We have energy. We have from tidal friction. We have liquid water, and we have the potential for chemical elements in that water from both the ocean floor and from impactors. And so it's, of course, a big celestial body of interest. And I think we're going to hear now about just how we're going to figure all these things out.
Absolutely. Yep. It's also worth pointing out, isn't it, that ice on the surface of Europa moves around. Because there are images, I think Galileo images again, where you can see the ridges running on the surface are not continuous. It's like if you like tectonic plates on the Earth rubbing alongside each other and moving laterally. So you can clearly see that the ice is cracked and it's floating on something, and the ice masses are actually moving past each other. So.
Yeah, they're slipping along because that chaos area, you could see it when Lou showed the slide of the chaos area. You could see stress marks or whatever you want to call them, and you could see that they've been slipped and they've been moved.
Yeah.
Just to make a big jumble. That's why it's called the chaos. zone. But it's very. We're looking forward to this probe.
Absolutely.
Well, assuming Hurricane Milton doesn't topple it over, we will have a launch in a few daes, I guess. Not a little bit
It's all
delayed.
doom and gloom today. What's going on? No comet. Now the rocket's got to fall over. Oh,
incidentally, as I announced on Facebook, because of Hurricane Milton, the launch for the Europa Clipper has been put back from Thursday until Saturday. Daz, can you remember the time?
It's to be announced.
No, they haven't announced it yet.
It's still a TBA from what I last saw.
Well, we definitely will be covering the launch here on Space Oddities.
I'll check again now.
Yeah, if you could.
I read 1719, but that might be out of date as well.
Right. Okay. Well, we will definitely be covering it live on Space Oddities, and this is such an important mission that even if it's in the middle of the night, we'll definitely get up for that and bring you the live coverage of the launch.
Yeah.
Although
if we can keep Michael awake.
Yeah, keep Michael awake, that is. So if you join us for the launch and there's a gentleman sitting there with a blanket over his head, you'll know it's Michael.
What's this? Get it not Michael night.
By the way, can I just answer a quick question before I forget about Jupiter? I know you're not going to believe this. I know this is very difficult to believe, but I was actually wrong about something. And in fact, Sandra, the red spot projects above the cloud tops of Jupiter, not beneath it. Yes,
we are seeing vapor.
Yeah, absolutely.
We're seeing material coming up from being upwelled.
Yes, it projects. The surface of the red spot projects not far above the clouds, only about 5 miles, but it goes down about 300 miles. So, as Lou said, the red color may be due to things like red phosphorus being brought up from the interior of Jupiter or other organic compounds. But
according to my research, there's a higher than normal amount of ammonia and acetylene in it.
Wonder why that would be. That's coming up from the interior, presumably.
Yep, and that's what they think the color may be due to.
Right, thank you, Aaron. Yeah, interesting. Acetylene, is that unusual to find?
I thought that's kind of
no. It's quite common. C2H2 acetylene, as we see it in Jupiter, Saturn, Uranus, Neptune, Titan.
Oh, right.
Oh, gas giants. Okay. In answer to the time, it is 1719, like Michael said. That's what I'm showing here now. But that's British summertime. Remember, BST.
Right. So we will
that'll
join
be
you.
About 1219 EST.
Yeah. So we will join you at 1700 BST on Saturday. Is that all right with you guys? You're going to be here for that?
Should be able to.
Yeah. Okay. So we'll join you on Saturday for the launch. Anyway, Lou, please continue. Sorry, we got distracted.
That's it. I'm handing it.
That's it. You're having it. Okay, right.
Okay, well,
thank you for that. Thank you very much for that. So this is the target for the Europa Clipper mission. Europa has intrigued us for a long time. Can I just again put in a plug for a wonderful movie that came out in 2012 called Europa Report, which is all about humans' first crewed mission to land on the surface of Europa. It's quite a low budget film, but it's absolutely beautiful, and I highly recommend it. It's a really, really good movie. Why it didn't get more attention, I don't know, but Europa Report is a great movie. If you have any problems tracking it down, let me know. Send me an email, spaceodditieslive@gmail.com. There we are. So what we're going to do now, having looked at Europa itself, and Lou has kindly told us, why it's such a target for exploration and why it's important to explore Europa, we're going to have a look at the actual spacecraft itself now. So, Michael, I don't see your presentation anywhere.
Bear with me a second.
Okay, Michael is just going to... okay.
Okay. Can you see that?
No.
I can, yeah.
Oh, hang on.
Well, we can't see the slideshow, no.
Why can't we see the slideshow? Hold on a second. I'll do that again.
You need to share the correct thing.
A good point. Hold on a second then. Bear with me. Stop sharing.
Would you let you expand it from there, Michael?
don't think so.
No. Okay then. Yeah.
Hold on a second then.
Okay. Just nice and tell viewers when while we get Michael sorted out.
Okay.
Okay. Thank you for joining us tonight, Neil. Thank you very much for being here. I haven't seen you for a long time, so lovely to see you back with Space Oddities. Take care, and hopefully we'll see you next week. So
that should be it now.
Okay, that's it.
Yeah.
Okay, just let me maximise that to get our ugly mugs out of the way.
Okay.
Right.
Great. Thank you very much. So this is mainly about the spacecraft itself. This is the spacecraft itself as an artist's impression around Europa. And it's basically going to ask the question or try and support the question if there is a life-supporting liquid water habitat that existing elsewhere in our solar system. So on Saturday, NASA's largest planetary spacecraft will launch atop a Falcon Heavy. So let's go into more detail. Okay, what's in the name? So Europa Clipper, the name harkens back to the clipper ships that sailed across the oceans in the 19th century. Clipper ships were renowned for their grace and swiftness. And this is the mission patch that's been designed. As you can see, it's got the there's a sailing ship there, there's a clipper ship. And to complement that, I've just got this one here. This is an image of the ship, the Cottysark at sea. A lot of you will have been to see this ship at the museum in London. And that was one of the fastest tea clippers that sailed the oceans. So that's where the name comes from. Originally, it was going to be Europa Orbiter, and as Lou said, there was going to be a lander as well, but that got pulled from the mission, and that is now going to be is proposed to be a separate mission in its own right. So I'll come back to that in a minute. Okay, so why Europa? Evidence of water was first suggested by ground observations from Kitt Peak Observatory in 1972 using spectroscopic observations. I can't say that word either. That was first suggested in 1972. Europa shows strong evidence of an ocean of liquid water beneath its icy crust. This is a photo, as Andy said, from one of the photos from the Galileo mission. And you can see all the different structures there with the ice on the surface. And again, the Hubble Space Telescope made its first detection of possible plumes on Europa in 2012. So that's an artist's impressions of what these plumes could look like. And in 2018, scientists revisited old Galileo data and found evidence that found evidence that Europa may be venting plumes of water vapor into space. That's an image of the Galileo spacecraft. If you're wondering why the antenna is like that, it was had to be kept in storage for several years after the Challenger disaster. So unfortunately wasn't able to deploy properly when it was launched. So that's the Galileo spacecraft. Okay, so this will be launched this Saturday, October the 12th, on a Falcon Heavy rocket. Falcon 9 with two side strap-on Falcon boosters as well. It takes a long time to get to Jupiter. It takes 5.5 years. There will be an Earth gravity assist in January 2026, and then a Mars gravity assist in February. Mars gravity assist in 2025, and then a Earth gravity assist in 2026. And Jupiter orbit insertion will be the April 2030. Okay, then the spacecraft will make an elliptical orbit around Jupiter, and it's designed that the spacecraft will actually make 49 flybys of Europa during its 5.5-year mission. So 5.5 years to get there, and a 5.5-year mission for the spacecraft. This is another artist's impression of what the scientists think Europa is like, with a large ocean underneath quite a thick ice layer, with plumes coming out of cracks in the ice. And that's what we're going to try and confirm with this mission. Okay, so this is the largest spacecraft for interplanetary flight that NASA has launched so far. So this is just a diagram showing how big the spacecraft is compared with the people, the size of people, and on the left-hand side. So it is a massive spacecraft. The spacecraft features the most sophisticated suite of science instruments that NASA has ever sent to the Jupiter system. And just showing how big the spacecraft is, the solar arrays had to be tested one side at a time. You can see how big the spacecraft is by the technicians on the left-hand side of the image. And that's just a close-up showing that particular slide.
It is, in fact, the biggest spacecraft that NASA have ever sent to a planet, isn't it?
That's right, yes, the biggest spacecraft, yeah. And I think it's the one with the most scientific instruments as well. So just added this slide, next slide. Lou mentioned the proposed the proposed Europa lander. As I said, the Europa Clipper was originally called the Europa Orbiter, and it was going to carry a lander with it, but the lander was split from the mission. And here's a artist impression of what that lander could look like. We don't know yet. It's not been funded yet, as far as I know, but that could be a mission to look forward to in a few years' time. Okay. So what I've got next, I've got a short video just to show what we're looking for in this mission.
New analysis of archival Hubble data revealed water vapor in the atmosphere of Jupiter's icy moon, Europa. Europa's icy, smooth surface, scarred by cracks and fissures, averages minus 275 degrees Fahrenheit, but researchers suspect a vast ocean lurks beneath that surface. The Hubble Space Telescope previously detected 60-mile-high plumes of water vapor erupting like geysers. These new results show water vapor over a larger area, suggesting a long-term water vapor atmosphere on one of Europa's hemispheres. This discovery lays groundwork for missions that will explore Jupiter's icy moons. Understanding the formation and evolution of Jupiter and its moons helps astronomers gain insights into Jupiter-like exoplanets elsewhere in the universe.
Okay, so that's the just a bit of background there. So scientific instruments then. Europa Clipper has a powerful suite of 9 instruments that will work in sync while collecting data. Information from those instruments will be layered together in different, images to show what the spacecraft has found. So the full array of instruments will gather measurements and images, and that will be used together to create the information that's being gathered. Okay, just a few slides now showing what the instruments look like. I won't be going into detail, but there's lots of technology here. This is the Europa imaging system, and next one is the Europa thermal imaging system, or eThermis. Europa ultraviolet spectrograph, Europa UVS. Mapping imaging spectrometer for Europa, or MISE. Here's the magnetometer. Strange looking instrument there. Plasma instruments for magnetic sounding, or PIMS. Sounds like a drink. Gravity radio science instruments. Radar for Europa assessments and sounding. Ocean to near surface, otherwise known as reason. What came first, the acronym or the meaning? And then we have a mass spectrometer for planetary exploration, stroke Europa, mass specs. And surface dust analyzer, or SUDA. Okay, so as I say, launch details now proposed for this Saturday at 17:19 UK time, BST. On Saturday, Launch Complex 39A at Kennedy Space Center, and launch vehicle is a SpaceX Falcon Heavy. Any more details you want to know about the mission, there's a website there. It's absolutely full of information about the mission. So go and have a look to see what you can find with that. But it's another 5.5 years until it gets there. So you've got plenty of time to read up on that before it gets to Jupiter. And that's it.
Great. Thank you ever so much, Michael. Okay, you can stop sharing your screen now.
Yeah.
There we are. Thank you.
Yes. Yeah, that's very good, Michael. Thank you. You're talking about the lander. The reason it was knocked on the head at the moment is that the Europa Clipper at the moment has cost them, I think it's something like £5 billion already.
Yeah.
And this was going to add another at least £1 billion to £1.5 billion in cost. So that's why they dropped it. And then, as you said, they were talking about using that as a separate go-to mission. So the end of the mission, the plan is at the moment to actually crash it into Ganymede, if I remember rightly.
Oh, right.
In the mission planning is they're going to crash it into Ganymede. They don't want to crash it onto Europa.
Yeah.
Because they don't want any possibility of a contamination.
Yeah.
Sorry.
It's like what Arthur C. Clarke said. All these worlds are yours except Europa. You've got to land on it.
Attempt no landing there.
Yeah.
If I could just add a little bit to this exciting history of funding, there is a senator from the state of Texas who took a special interest in this concept of a Europa mission. And in fact, in the 2013 Planetary Decadal Survey, the Europa mission was not highlighted. It was there, but it was not given top billing. Oh. And yet this senator pushed hard for it, and I think put a hard line item in the congressional budget. So NASA had to do it. And NASA went through with their plans to develop orbiter and a lander. Of course, the surface is what's so interesting, I think. And that worked out well until this senator got voted out of office. And at that point, my understanding is that's when the mission got rescoped to just an orbiter.
Okay. Oh, right. Okay. Yeah.
Politics again. Politics.
Sounds about right, doesn't it?
Yeah. Can I just say, the problem with developing these spacecraft, it's a very long-term thing. They take years to develop.
Yeah.
And by the time the spacecraft flies, the technology on them is often very old. Now, this is particularly noticeable, of course, with the resolution of the cameras. So I'm pleased to report that the camera on the imaging system is an 8 megapixel.
Wow.
Yeah, which obviously is nothing compared to even what you've got on your phone.
That's right.
But this is because these things take such a long time to develop, and the technology ages rapidly. But that works out to a resolution of Europa at about 300 feet per pixel.
Yeah.
So,
and I have a 48 megapixel camera on my phone.
Now you're just showing off.
The new Samsung is 100 megapixels.
Oh, right.
Yeah.
Okay.
Well, clearly they need to be putting cell phones on these spacecraft.
Exactly. That's all.
It's not a measuring contest, lads. It's not a measuring contest.
But what do we know? What do we know? We know that doesn't necessarily make a difference, because you, viewers, as citizen scientists, can then download those images and enhance them and make them look a lot better and bring out more scientific detail. So it's not necessarily a bad thing, although, you know, it does demonstrate how long these missions take to develop. I can't remember when I had something resembling an 8 megapixel camera, but it was many years ago, obviously. So there we are.
Yeah, because this was first proposed in 1997.
Yeah, there we are.
Okay.
Yeah. So,
Well, and the thing is, no matter how good your software is at enhancing the picture, if it's 300 meters per pixel, it's 300 meters per pixel.
yeah, absolutely.
Right. Yeah.
You can't get more information out than was originally in the image. Which, in a sort of related note, when you see all these old black and white films that they've upscaled to 4K, it's ridiculous, because if the information isn't in the original footage, you're not going to be able to bring it out.
No.
So you know, it's a bit of a con, really. People buy these things on Blu-ray or Super Blu-ray, expecting fantastic.
Like when people have asked me to enhance or try and make an image better, you know, an old print of an old black and white image or something.
Yeah,
you just can't do it because
you can't do it.
The information's not there.
No.
You know.
So that was very interesting when Hubble was launched, and of course the optical system just produced blurry images.
Mm.
And before they could put the new glasses on Hubble, they were doing things with these images to clear them up. I thought, this is not real. You can't do this. Now, I don't know what techniques were used or how real the eventual image was, but they were there. Perhaps, as Dumbledore said, I'm afraid there are ways. So
yeah, absolutely. But anyway, we hope you can join us on Saturday at 1700 BST for our live coverage of the Europa Clipper launch. If there are any changes to that, we will of course let you know on the Facebook page. But so far, things are looking good for Saturday. We should of course wish the people of Florida the very best in face of this monster hurricane that is about to sweep across Florida, probably coming ashore somewhere near Tampa. And you know, this is without doubt, or so far, the biggest hurricane of the year. It's currently Hurricane Force 5. It's expected to be Hurricane Force 3 when it makes landfall. But, you know, that is still a hell of a powerful hurricane. So I'm sure everybody's thoughts are with the people of Florida at the moment. It's probably going to make landfall late on Wednesday. So
I think the governor and maybe other members of FEMA have said, if you plan to stay and you are in the region that is being evacuated, but if you plan to stay anyhow, take a felt tip pen and write your name and birthday on your arm so that we can identify your body.
Oh, nice.
Wow.
They're really...
Well, that's cheery.
That's cheery note.
Well,
yeah.
I know it's a bit bleak, but that's why you have to sit in your designated seat on a plane.
Yeah.
So that you know, they say it's for balancing the plane out and all that. Is there?
It would be in your case.
I get 3 seats. What are you on about?
But if you're going to write on your arm with a felt tip pen, make sure it's a permanent marker so that when you sink to the bottom of the water, it doesn't come off.
Well, good point.
Yeah, I know we're being a bit flippant, but you know, be safe.
You heard it here first, guys.
Yeah, absolutely.
Yeah.
I mean, of course, they've only just got over the last hurricane, which delayed the Polaris Dawn mission.
Oh yeah, that's right.
So you know, they're still recovering from that. So it's a nightmare for them. But we'll be thinking of you. So everyone, please stay safe.
Yeah, stay safe. And let's hope this is last big hurricane of the season. Although, contrary to what Donald Trump lied about, it's not the end of the season. It's only about halfway through. So, undoubtedly, there were more hurricanes to come. So, we hope everybody will be safe. All right. So, hope you enjoyed that about Europa. If you have any questions, put them in the chat. If you think of any afterwards, put them on Facebook, and we'll do our very best to answer them. And don't forget that wonderful film Europa Report from 2012. Really good movie, and I thoroughly enjoyed it. Watched it a few times, so highly recommend it.
I like this one.
Which one? Oh yes, absolutely. Yeah, still using Windows 98. Yeah. Windows 98 was actually a good operating system. You know, these versions of Windows, they alternate in being really good and really bad. Windows 98 was a good one. And then, of course, it was Windows ME after that.
That's right,
the
yeah.
Millennium Edition, which is probably, until Vista, it was probably the worst version of Windows ever. But there we are. Yes. Kenneth says, if I would love in that region, I think he means if I would live in that region, my house would be a concrete igloo. Absolutely. Yeah, I'm with you on that. Definitely.
Reinforced concrete igloo.
Yeah.
Commonly known as a bunker.
Yeah.
Yeah, I mean, the hurricane has currently got winds of about 165 miles an hour.
Oh, wow.
Which is outrageous. And they were predicting earlier it might get up to about 180.
Oh.
So, an incredibly monstrous storm coming in.
Yeah.
Anyway, moving on from that, what are we going to now? Well, I guess there's only one place to go now, as we always do towards the end of the show. By the way, we hope you've enjoyed yourselves tonight, viewers. And thank you for all your questions and comments. What we do towards the end of the show is we go over to the man who will tell us exactly what's been going on with our nearest star. That's the sun, for those of you that didn't know. And Daz, it's been a bit of a disappointing week in ways, hasn't it?
Towards the end, yes, unfortunately. So this is cocoa time. Everyone get ready for bed. So let me begin. Here we are. Oh, you've just done it for me. Thank you, Andy.
That's right.
Right. First of all, I have to control tab. Can everyone see that?
Yes, and we can see your cursor as well.
Thank you very much.
Yes, indeed.
Right. Okay, then we'll start with usual. On the left, 1st of October. That was the sun we left with last week, and region 3842. Yeah. Sorry, for a minute I thought I got them wrong. 3842. It's just here. In fact, this isn't right. So forget this. We'll forget this one because 3842 was over the eastern side. So I've put a wrong slide in here. It's in the right place on the 8th of October. As you said, Ian says if there wasn't a mistake, it wouldn't be Daz presenting. So there we go. So we'll forget that one. So what's on the right hand side is what we've got today. They've got that massive spot right in the middle there, near the equator and in the center, which is 3848. Now that's been a bit of a disappointment. It looks lovely, but it's been totally a bit of a disappointment. The one that's been the bad boy all week is 3842, which is now, as you can see, on the western limb. It's just going to disappear, but it's not going to go quietly, and I'll tell you why in a bit later on. Right, so let's get out of here. So, literally, what a difference a week makes. This is basically what happened is on Tuesday. As I said, I was bemoaning how slow everything was for about the last 2 or 3 weeks. Then on Wednesday, lo and behold, 3842 comes along. And Wednesday and Thursday, late Thursday, it fired off 2 X flares. One a 7.1 flare, and then on the late Thursday, it was an X9 flare. So we had those to contend with. When it fired off the X9 flare, it was almost in the center of the actual sun. So we knew we were going to catch something from this. Plus with what had happened the day before. And literally all week, we've been having flares after flares after flares. Now it's only 96. Now I know sometimes I'm saying, oh, we've had 120, 130 flares, but they're always the C-class flares. But we've had 96 flares, and the rest of them were virtually all M-class flares. We've had lots and lots of M-class flares, and as I said, we've had beginning of the week we had 2 X-class flares, and we literally finished last night with another 2 X-class flares, and I'll tell you about those in a second. So here's the synoptic map. If you remember what I've said about this, we've got 3 coronal holes showing here. That's these little pond things here with the dashes coming inwards. These indicate coronal holes. We've got 3 of them. Now, this one on the western side, right by 3842, didn't exist until we had that X9 flare. And then it appeared literally. Now, whether or not that was the reason why it came to the surface, I do not know, or whether it is interacted with that, I don't know. But it was very strange that we had the X9 flare, and literally moments afterwards in the imagery, you could see this dark spot forming, which was the coronal hole. So we've still got the big one at the top. As you can see there, that's a positive hole. There's another positive hole, and this one's a positive hole. Again, remember, you've got your neutral lines here. These are flares that are sitting on these neutral lines, and these are actually the active regions, and they're numbered, as we said before. I'm not going to go through it all again. But as you can see, if we look up the top here for the whole disk, of course, we've got 99% chance of C flares, 75% chance of M-class flares, 30% for X flares, and 30% for a photon storm. So yeah, it's not a photon storm, a proton storm. So yeah, so there's still big expectations for activity to happen at the moment. So okay, then so what we'll do is we'll move on. Now, as I said, this is the usual things. I've made these a bit faster because there's a lot to go through. Right, so we're just going to come up to the 9 flare. If you look where my cursor is, this is the region we're looking at. You won't see much in this. You will see actually something just lift off. It just did then. That was it. So in this wavelength, you're not going to really see much. You're just going to see the reconnections and possibly a bit of a flash. So we'll just let this one run out. You can see it's right over to the far end, but keep an eye on it because there's going to be right at the end there, bang. That was the 2. And there's actually 2 flares there. There was one almost right afterwards. This is a better. There goes your first flare. That was a 7.2. We come along. It does a couple of other little things. You can see there's other activity going on. There was your 9. No, here comes your 9 flare, if I remember right. You'll see it light up. Oh, it's gone through. So, but again, watch as it comes towards the edge, and you will see that there is a big. You can see the actual plasma being thrown out into the atmosphere. It'll be coming up soon. So right towards the end, bang! Look at that. That was the 2 flares that happened last night. Now I've pulled this one right out. This is using all the LASCOs. And the reason I've done it is look towards the end. You're going to see all these expulsions. Remember, some of these expulsions are from the far side, but you can see them coming along. If you want to check the times, just have a look at the bottom left-hand corner. But as we get right to the end, there'll be a surprise coming in, and this should make Roger smile. So as you can see, all these things are still kicking off. We're getting right to the end, and look what's appeared. It's Tishison Atlas. It's the comet.
Wow.
So there you go. And of course, tomorrow it'll be. I can probably do another one of these, and it'll fly over the actual thing. But that's what that is. That's the actual comet that's in the sky at the moment that we've all got great hopes for, Andy. We've all got great hopes for.
Absolutely.
So yeah. So a nice little surprise at the end there. We've actually got a comet, a big comet as well, as you can see. It's absolutely gorgeous. What I will possibly do is I'll just do a couple more of these over the next couple of days and see how big it's. Well, it'll only be tomorrow because it's moving. The whole thing's moving quite fast. So we'll see how big that tail actually is caught in the actual LASCO chronographs. So here we go. Right. Now this is in 131, as what I normally do. And again, this is all week, and you can see this will give you an idea of what the flares are doing. They're very, very bright. We just had the 7.2. That's another flare. Then we'll get the big flare, as you will notice. Yeah, you didn't miss it then, did you? And then it'll carry on. You'll see there's other little flares. Like I said, there was lots of M-class flares going on as well. And most of these were produced by this, what does it say? 3842, was it? 3842? Whatever number it is. Yeah, so, yeah, 3842. And right at the end, again, you'll see it flare off right at the very end. So, bang, there it goes. Look at that. Obviously. So we had all this action, and we were hoping for. Oh, these are just some images of these separate flares in case you missed them. But of course, I did these two because I thought, right, I'll start preparing it and stuff like that. Because 742 had been quiet for a little while. I didn't think we were going to get anything. But yeah, so this was on the as you can see at the top, it's the X7.1 flare. On the right, it's the X9 flare. But then I had to put this one in because it's the two flares that happened today. They're not very big X flares. The first one was 2.2, and then literally within 2 hours, it was less than 2 hours, we had an X1 class flare come off of there as well. But as we said, usually, as I've always said, it's right on the edge. So most of this is going to be going to the west, but without checking the halo, we're not sure whether or not it will actually come our way. We will see. We might get something from it, but we will see. So I'll just move on. Right, this is what date's this? 3rd to the 4th. So this was the 9 flare. I keep losing my cursor, so I can't see it. So I'll just run that again for you. But as you can see, it's not just one flare. There's 2 or 3 flares there happening all at the same time. I'm really getting annoyed with this cursor. So let me try again. So there we go. You can see it's 2 or 3 big flares going off at the same time. So let's just move on to the next one. This is a still. And look, you've got 1, 2, 3 flares there. And then right at the end of this, this is actually a still from the actual video. There is another big flare off towards the top right, where this one is now. So there was another one. So you had about 3 or 4 flares all going off at the same time, and this is what we said we were expecting big things from this, and we were disappointed, but also we weren't. I'll explain why in a second. Right, so there we go. That was the 2 flares that happened today. So I'll just show you that again. Bang. You can see them firing off. And you can see there is 2 slightly different angles to them. So I'll just do that again for you. Bang, bang. So there we go. Then maybe we'll catch something from this. Right, so this was the predictions. Right at the very beginning, you could see we were expecting these flares from the 7.1 and the 9 to arrive. What we got here? But on the 5th and the 6th. In fact, the first one was expected to arrive on the 4th, but the main event was supposed to happen over the night of the 5th and 6th. So, unfortunately, it didn't happen. Also, as I will show you in a minute, the BZ, which is the interplanetary magnetic field within the actual solar wind, was north. So if anything had hit us that time, we wouldn't have noticed any aurora as such. So it's probably a good job it didn't. So we were all very disappointed. We're all licking our wounds. And then, of course, then we had the 2 events last night. And I'm assuming that's what this big blip is here, this big peak here. They're expecting it to arrive earliest on the 10th. Now, this is for the UK, this one. So remember, this is from the Met Office, the UK Met Office. So this we're expecting possibly about the 10th and 11th. But as I said, just hold your horses, and we'll see what actually happens. But as I said, this was supposed to arrive the 5th of the 6th, but lo and behold, as like I said, this is before the 4th and the 5th. Look, I'm looking at the red line. It's all above this dotted line. For us to get aurora, it has to come below this line. If it's all above, that means the solar wind has a magnetic field complexity of north. And that doesn't give us auroras. We don't get auroras when it's north. It has to link up with our own magnetic field. So that was one of the problems. You could see also there was a slight rise. There was no massive jump because we were expecting all these things to pile up and give us a big shock wave, and that never happened. It rose slowly. You can see all these levels rising slowly. So basically, we didn't get the big slamming effect that we were hoping for, which then again would have given us aurora, but we were still north facing. The magnetic field in the solar wind was north facing. So there we go. But what happened was on the I've got this thing over me thing. What's this? But back just at the end of the 6th, towards the end of the 6th, we're still heading north, and all of a sudden it drops down. So the BZ became south, and that's what we've been looking for. So it did go back up into the north for a while, but then it came over here, and you can see it's remained south for quite a long time. And luckily for us, for some of us, this is what happened. The actual main event arrived 24 hours late. But this of course is UK. As you can see, these are the K results for each station, and this is the KP result, which is basically a average from all of the because I said from each station it's called the K index. The KP index is a average over all of the global stations, and as you can see, it actually reached above G3. Now that means that we had aurora down to quite low latitudes, mid latitudes. Oh, sorry, I didn't mean to do that. Spoiler alert. So we went down. So I know that Mary McIntyre, a friend of the show, she was able to capture images of the aurora, nice pink aurora. I saw. If you go on YouTube and type in Mary McIntyre,
Mary Magdalene.
Yeah, I know. I was having a religious moment then. But then we went. If you type in Mary McIntyre aurora, and you will be able to see her images from what were we on Tuesday? Yeah, yes, Sunday night, Monday morning. So, and I have seen lots of other things. Unfortunately, I was clouded out, and also I didn't hear me alerts go off. So, because I went to bed early. How sad's that? Anyway, so we did have an event. It arrived 24 hours later. This is all going back. I haven't checked it recently, but yes, it's all dropped down. But as we said, this all could kick off again in another couple of days when these other two events happen. These are the sunspots for the active areas. Sorry, I do apologize for the what we have at the moment. Now, this during the midweek, in the middle of our week. Remember, we go from Tuesday to Tuesday. These were all virtually all red. We had about eight active regions, and literally 6 of them were all red. And some of these, there was about 3 or 4 that had 3 letters in this. And remember, this is what I said. This is indicating the complexity within each active region. The more letters there are, the more chance that they are going to give us something exciting. As you can see, 3842 from last week has lost 1 number. I think it's lost the delta off there, but it is growing again. But it's just going off the west limb. And as I said, it was determined it wasn't going to go quietly into that dark night. And it fired off 2 X flares last night. So I hope that explains why we didn't get the weekend of auroras that we were expecting. It arrived late, but also the interplanetary magnetic field had to change to south, which it did for us. So people were able to get out last night. So there you go. So what's coming? Well, as I remember this is the west limb. This is all the stuff that's leaving the sun's. This again is a couple of days old, I do believe. Yeah, it's the 7th. So it's only yesterday actually. But the 3842s are closer. These are just coming on. Now these were not visible about 2 days ago. These have grown and they look quite dark. And they've just started to come onto the eastern limb. This one's moved on now. It's just a little bit on, so we've got more of an indication of what that one is. So this is what we've got. There's more action to come. But again, if you noticed, it's moved up into the north. Whereas we've had most of the activity in the south, now the north's becoming more active again. And it was quiet for a very, very long time. So what the sun's decided to do, I do not know. The sunspot count is up again. So that's going to be interesting. The results for last month are in, and look how far it's dropped. It was up here last month. It's dropped all the way down to here. I think that's September the 24th. The average was 100, the monthly values was 141.4 sunspots. So just to compare that to last month, let me just move on. This is two side by side. So that was September. This was August. And as you can see, there was 215.5 compared to 141.4. So as you can see, and as I said, this week the averages are back up again. So it's a watch this space scenario. I mean, it's going to keep us guessing before we can actually notice that there is a full decline. But as I said, if we do go into the decline, it doesn't mean the action's going to stop. In fact, in past cycles, sunspot cycles, the activity sometimes has increased greatly. So we could still be coming in for some good shows. So let me have a look. Oh, that was something else I'm working on. So yeah, okay. So that's it, folks. I hope that explains what's been going on to us all. And hopefully this week, keep an eye out for the night of the 10th and 11th, which is predicted to be another peak, possibly with some more geomagnetic storms. We will see. Keep an ear out for your alerts, and don't go to bed early that night. No. Okay, then. Everyone take care.
Right, thanks, Daz. Thanks a lot for that. As always, very interesting. Just before we go, just a couple of things to finish off. If you know of any space astronomy events happening near you, don't forget to put them in the Your Astronomy Events chat in the Facebook group so that everybody knows they're happening. That's that. And that would be very useful if you could do that because, we have people living all over the place and somebody might see it and say, oh, I could go to that. So do publicize astronomy events that you know are happening wherever you are. Doesn't matter where you are. And that's that. And I think we'll just draw things to a close for this evening. Now, next week...
He never misses a trick. Look, I wonder what a photon storm would look like. It'd be very bright.
Yeah, absolutely.
It says, and Ian also asked something about, what was this? Does this apply to the Borealis? Wouldn't the Australia still appear if the BZ was north? No.
There you are.
It won't. Remember, our magnetic field goes from south to north, so we need that south to connect. So it wouldn't happen. So yeah, the auroras do not happen. As I've said before, go back and look at some of the other shows. We have to have that south component in the actual geomagnetic storm itself for it to actually happen. So thanks for that, Ian. That hopefully that'll explain it for you.
Next week on Space Oddities, we are delighted to welcome Robin Hoover as our guest. Robin is European head at Saxaboard, the UK spaceport in Shetland. So Robin will be telling us all about what's going on there and with the British space programme. And we look forward to greeting him on Space Oddities next week. Don't forget, at a time and date we are still discussing with the team at Polaris Dawn. You may remember the Polaris Dawn mission from a few weeks ago. Well, we are very honoured to say that we will be greeting 2 of the astronauts on Space Oddities soon. That is to say, Anna Menon, who was the medical officer, and Sarah Gillis. We will be having a chat with those 2 astronauts live on Space Oddities soon. Not quite sure when. What we are trying to arrange with the Polaris Dawn team at the moment is an educational event where schools from the UK and the US can take part simultaneously and ask their questions here on Space Oddities. That's what we're trying to arrange, but we will keep you posted on that. But it will be happening in hopefully not the too distant future. It'll be wonderful to hear about the experiences of the Polaris Dawn astronauts firsthand. So we've got that to look forward to. As you know, on Space Oddities, we're always trying to bring you the very, very best in guests of people you might like to listen to and watch. We also, coming up, you may remember Mr. Brian Harvey, science author, who was on Space Oddities a little while ago. He had big problems with his audio, and we had to more or less scrap the chat with him, unfortunately. Well, tomorrow we're recording an interview with him, which we will play on Space Oddities very soon. So you've got that to look forward to again, because unfortunately Brian couldn't communicate that well with us because of his audio problems. But hopefully tomorrow we'll get a good recording in the can, and we'll show you that on Space Oddities very soon. So I think that's it. I'd like to say a big thank you to Aaron. Are you still with us, Aaron?
Yep, I'm still here.
Oh, good. Well, thank you for being here.
Lovely hearing from you.
Yeah, lovely hearing from you today. I hope we get your camera problems sorted out soon. I'd like to say thank you to Lou, who's had to rush off, unfortunately. Had a pressing engagement. And thank you to him and Michael tonight for telling us all about the Europa Clipper mission and the enigmatic moon itself. Don't forget, Saturday at 1700 BST, we'll be live bringing you the launch of the Europa Clipper, presumably. Keep your eye on the Facebook page for any alterations to that schedule, but it's definitely go for 1700 BST at the moment on Saturday, and we hope you can join us. Let's get this spacecraft on its way to Jupiter. Don't forget, of course, that it's not the only spacecraft on its way to study the Jovian moons. We've got Europe's JUICE mission, the Jupiter Icy Moons Explorer, which was launched last year, I think, wasn't it now? Was it last year? Yeah, it was launched last autumn. And that's got a year ahead of the Europa Clipper. And Jupiter Icy Moons Explorer will be investigating not just Jupiter, but also Callisto and Ganymede as well. The other two of the other Galilean moons of Jupiter, Io being the other one, of course.
Mm-hmm.
Oh, sorry, Michael, it looked like you were about to say
something.
I
was just thinking about what you were saying. We've also got the Lucy mission to the Trojan asteroids as well.
That's right.
Yeah, on its way. Yeah,
that's right. So we've got lots of spacecraft in the air, as it were, on their way to various targets in the solar system. So that's it. So let's get Europa Clipper on its way as well.
Yeah. Didn't JUICE just do a gravitational assist around the Earth? And then it's doing another one round Mercury, is it?
Yes.
No, not Mercury.
No, it can't be Mercury.
No,
Venus.
Venus, I think it was. Yeah, but anyway, that's it. I'd like to say thank you to Roger for his guide to the night sky and the viewers gallery. As always, thank you, Roger.
Viewers.
Sterling work.
That's all right.
And we'd like to thank you, our viewers, for being with us tonight. Don't forget to join us next week for our chat with Robin Hoover of Saxavold. And we'll look forward to that. But we hope to see you on Saturday for the live launch of Europa Clipper. So from all of us at Space Oddities, thank you so much for being here. We do appreciate it, as always. And we'll see you next time. So from all of us at Space Oddities, have a fantastic week. Take care of yourselves. And thank you for being here. All the best.
Keep looking up.